Hello and welcome back. In our previous video we got the eigenvalues, and it's a 3 by 3 matrix, so we expect 3 eigenvalues, of which we got our 3 eigenvalues. Our first eigenvalue was lambda is equals to -2. We had lambda is equals to 4 and lambda is equals to 3. Today we are going to use the eigenvalues we got here to find our eigenvectors. You remember our characteristic polynomial was lambda I minus a. We were getting the determinant, which was equals to p subscript a lambda to represent our characteristic polynomial. So we're going to use each of the lambdas to get the corresponding eigenvector. We will begin with lambda is equals to 3. You can begin with any that you like, but let's begin with lambda is equals to 3. So we substitute back in our equation. We will have 3i minus a is equals to 0. And now here we are using the normal brackets. And wherever we have lambda, we are replacing with I with a 3i. So we are going to have a diagonal matrix which has values 3. So we will have 0, 3, 0, 0, 0, 3 minus our matrix A, which was given as 1, 0, 3, 2, 3, 2, 3, 0, 1, and then we have x1, x2, x3, x1, x2, x3 will be equals to 0. This one is a column matrix because it has only one column. We will go ahead, simplify further our matrix just by doing the normal subtraction. 3 minus 2, this is everything is corresponding. 3 minus 1 gives us 2, 0 minus 0 gives us 0. So we have 2, 0, -3. When we subtract, we get -2, 0, -2, and then we have -3, 0, 2, 1, x2, x3 will be equals to 0, 0, 0. So we have to do the row reduction and simplify this matrix completely. We're going to write it as an augmented matrix. We will have 2, 0, minus 3, minus 2, 0, -2. Then we have -3, 0, 2. We're going to put 0, 0 before we proceed. So you can see that if we add row 2 plus row 1, our row 2, so we will have row 1 plus row 2, and the impact is going to row 2. And then we can also clear row 3 by having 2 row 3 plus 3 row 1. Everything also goes to row 3. And now our new matrix will look like this. We will have 2, 0, -3, and then we have a 0 here. When we continue, we will have 0, 0, -5, 0, and then 0, 0, 0, 0. So you can see we cannot simplify further than this. Everything in x3 is 0, so that means x3 will be 0. However, in x2 we have -5 is equals to 0, so we will presume that x2, we will make x2 to be t. And when you simplify everything else, you'll also get x1 is 0. And now that gives us our first eigenspace. So our eigenspace for lambda gives us, let's just write here, we have eigenspace, and our eigenspace is 0, t, 0. T is a real number. What does this mean? It means you can use any real number you want. And in our case, for instance, we can say if t is 6, you'll get 0, 6, 0. If t is 1, you'll get 0, 1, 0. In the same manner, we go to the next step. We have lambda is equals to 4. We have lambda 2i minus a, and then we have x is equals to 0. But now our lambda is 4. We have 4i minus a, and then we multiply by x, our column vector. We are going to do the same subtraction. We will have our diagonal matrix 4 0 0 0 4 0. Then we'll have 0 0 4 minus our a, just like in the first step, 1 0 3 2 3 2 and 3 0 1. We are going to subtract them, then multiply by our column vector x1 x2 x3 is equals to 0 0 0. What will we get when we simplify? We will have our matrix 3 0 negative 3 negative 2 1 negative 2 negative 3 0 3. x1, our column vector x1 x2 x3 is equals to our column vector 0 0 0. The same thing, we're going to create an augmented matrix here so that we can carry out the row reduction and get our value for lambda 2, and the procedure is the same. We have our matrix, and our matrix is 3 0 3 negative 3 here. We have 0. Our second column will be negative 2 1 negative 2 negative 3 0 3, then 0 0. We're going to do a row reduction. We will have 3 row 2 3 row 2 plus 2 row 1 on row 2, and then we will have row 3 plus row 1. Our values here will become 3 0 negative 3. We're just performing a row reduction, and when performing a row reduction, your aim is to get the matrix column, the diagonal matrix with 1 in the diagonal. But sometimes you can't get that, so we just simplify. You will get here like 0 3 negative 12 is equals to 0, and then we will get 0 0 0 0. And now we are going to have x3 is equals to s. That means 3x2 minus 12x3 is equals to 0. 3x2, but we have said x3 is s, is equals to 12s. That means x2 is equals to 4s. And now we are going to get x1. We have 3x1 minus 3x3 is equals to 0. That tells you 3x1 is equals to 3x3. The 3 and the 3 will divide, so x1 is equals to x3 is equals to s. And now we have will be equals to 4s, whereby s is, meaning you can choose any value. You can say if s is 1, then you will get your eigenvalue to be 1 4 1. You can choose s to be 2 or s to be any real number, because you have said s is a real number. And lastly, we have x is equal to not x, lambda 3 is equal to negative 2, our last eigenvalue. We're going to have negative 2i minus a. We have x is equal to 0. The same procedure, going to have a diagonal matrix with negative 2's. We have negative 2, 0, 0, 0, negative 2, 0, 0, 0, negative 2. Then we subtract 1, 0, 3, 2, 3, 2, 3, 0, 1. What do we get here? And remember, if I forget, we have x1, x2, and x3, our column vector. Let's just delete everything from that point. So we have our column vector x1, x2, x3 is equals to 0, 0, 0. We will follow the same routine that we have, and after our subtraction we will get 3, negative 3, 0, negative 3, negative 2, negative 5, negative 2, negative 3, 0, negative 3, x1, x3, which is equals to 0, 0, 0. The procedure is the same. We create an augmented matrix and then row reduce the matrix. We will have negative 3, 0, negative 3, negative 2, negative 5, negative 2, negative 3, 0, negative 3. This is 3, and then we will have 0, 0, and 0. So you can see, if we row 1 and row 3 can eliminate. So we'll go ahead and add. We have row 1 and row 3. We have minus 1, negative 3. We're going to subtract, because negative 3 minus 3 will give us 0. So we're going to have row 3 minus row 1, and that gives us, and also we can have let's say 3 row 2 minus 2 row 3. And that way we will have negative 3, 0, negative 3, 0, minus 15, 0, and 0, 0, 0. After row reduction, so we can continue. We will have x3 to be t. x3 is t, and t here is a real number. x2 is minus 15. x2 is equals to 0. That means x2 is 0. And then we have negative 3x1 minus 3x3 is equals to 0. That shows minus 3x1 is equals to positive 3x3. So x1 is equals to minus x3 is equals to minus t. And now we have the three values for x1, x2, and x3. We can comfortably come up with an eigenspace. Now we will have eigenspace this will be negative t 0 t, and now t is a real number, meaning to get the eigenvalue we can say t is equals to 1, and now we have negative 1 0 1. Kindly note that you're not limited to using 1. You can use 2, 3, or any other number as per your convenience. Thank you for joining us today.